So there are some numbers for x that you could plug in here that would make this turn into 0. And we have something called the rational zeros theorem that's going to help us tell what numbers for x that we can plug in. You know, before you might have worked with quadratics where you factor a quadratic and then solve it by setting each factor in equal to 0. But in this case, for a broader one where it's cubed or for where it's raised to the 4th power, we have the rational zeros theorem, which will tell us all the possible answers. So the way the theorem works is that we take the factors of the last number in the polynomial in descending order, and then divide it by the factors in the first number in the polynomial. So sometimes this will lead to a lot of different possible answers, but let's look at the factors of the last number, the -2. You can divide 2 by 1, a positive or a negative 1 will fit in there evenly. Or you can divide 2 by a positive or a -2, and that will fit in evenly. And that's all the options. But now we need to consider all the different factors of 3. You could divide positive or -1 by 1. Positive or -1. Or you could divide that also by 3. So here's the positive, or oops, that should be blue. Here's the positive or negative option again. We could also divide that by 3. That needs to be a factor here. So the same goes with 2. We got positive or -2 as a factor of -2. Now that could be divided by the one of the factors of 3 is this one. There's another combination that we can make there. You could divide that by positive or -1. Kind of went out of order there. I did 1 first here. But the big idea is that it's the combinations of all the factors lists all the different possible answers. So in this one, you know, there's quite a few. Positive 1 over positive 1, -1 over positive 1, or, you know, you don't even need to consider -1 over -1 because that's positive 1. So from this first number we have here, positive 1 divided by positive 1 will give you positive 1. Positive 1 divided by -1 will give you -1. Those are some factors, some possible answers we get out of this combination. Now this one we could have a positive 1 over 3. You could have a -1 over 3. And that's all the options for this one. For this one you could have a 2 over 3. Or you could have a -2 over 3 as an answer. And then from this last one you could have 2 over 1, which is 2. Or you could have -2 over 1, which is -2. You could have -2 over -1, but again, that would just give you back to a positive 2. So this is the full list of all possible answers to this red equation up here. You know, it's a lot. Most of them aren't going to be solutions, but at least we have a list that we can narrow down now for the red one up here. At this point, you wouldn't be blamed for thinking me to be crazy to ask you to plug each and every one of these in to find out which ones are the zeros. A better way of doing that, though, would be to look at the graph of this equation. Punch that in the graphing calculator, which I'm going to put over here, and then see where it crosses the x-axis. And you should be able to scratch off some of these. Okay, so let's graph it. So here it is off to the side, the graph of the function. So you can see it pretty much, it looks most likely across that -2. Well, that looks to be about -2/3. Okay, it doesn't look like -1/3. We're going to go with -2/3. And that looks like 1. So if you plug in these three numbers, -2, -2/3, and 1, that's going to be solutions to this. Okay? But a bigger reason for why we pick this out is because now we can rewrite this expression. Now if you use long division for this guy, and let's just take -2 for example. We're going to divide this polynomial. We're going to divide it by x plus 2, and here's the reason why. Because if you divide by x plus 2, down here, -2 would be a solution to this. And if we can factor out a -2, we'll have something like, this, x plus 2, and then the quotient, which is all this stuff when we've used long division, and then plus some remainder. Okay. But in this case, the remainder is going to be 0 because we know that this is going to be a solution. So we've chosen a number based on our graph, based on the remainder theorem, that's not going to have a remainder. And so that when you plug in -2 here, -2 plus 2 gives you 0, and 0 times all this stuff will give you 0. Okay, so let's do that long division here. We're going to divide this by this. Okay, and using that long division, we need a number to multiply to x to give us 3x to the third. So that number is going to be 3x squared, because 3x squared times x gives us 3x to the third. And that is a consequence we have to carry through. 3x squared times 2 will give us 6x squared. Okay, and when you use subtraction to make these things cancel out, 3x squared minus 3x makes nothing, but 4x squared minus 6x squared gives us negative 2x squared. And then we got to carry down the negative 5x. And again, we need to pick a number so that when it multiplies to x, it'll give us negative 2x squared. So that number is negative 2x. Oops, I shouldn't put a plus. It's negative 2x because negative 2x times x gives you negative 2x squared. But now carry through. Negative 2x times that 2 gives you, that gives you negative 4x. So don't forget, this is subtraction. So subtracting a negative makes these cancel out, just like we had this cancel out up here. But negative 5x subtracted by negative 4x gives you negative 1x. Oh, gosh. There we go, negative 1x. And let's carry down the 2. Now we need a number to multiply to x to give us negative x. That number is negative 1. So carry that through and multiply it to everything over there. You know, negative 1 times x gives us negative x. Negative 1 times 2 gives us negative 2. Everything perfectly cancels out just like we said up here. That's why the remainder theorem gave us something that would make everything perfectly cancel out so we didn't have a remainder. So, finally, we saw that if you use your, if you rewrite this, this is the divisor that we used, and this is the quotient, and there is no remainder. This is all equal to 0. That's what our red equation is turned into. So you can see x equals negative 2 was definitely a solution. Now all you have to do is solve this. Find out what it's going to take. And by the way, that's just a scratch mark. I can't erase that. This is a squared. Now all you have to do is solve this as a quadratic equation. Okay, plug in all this stuff into your quadratic formula to find your other solutions. And you'll see when you use the quadratic formula, you get negative 2/3 for a solution, and your other solution using the quadratic formula is positive 1. So there, the rational zeros theorem gave us a list of possible answers. We looked at the graph to try to figure out which ones would be best. It looked like it was going to be negative 2, negative 2/3, and 1. So we factored out one of the zeros. If you have x plus 2, if x is negative 2, that would make a 0 come out. So we chose to factor out an x plus 2 to make that happen. And when you factor it out and rewrite it using techniques we practiced before, rewrite it using the factorization theorem, you have this, and then solving each parenthesis, setting it equal to 0. This one's easy. That one's negative 2. But this one, you just needed the quadratic formula that gives you this.